Hello friends, in this tutorial we will be dealing with the basic strength of material concepts, that is elasticity, the concept of stress, what is stress, and concept of strain, and the stress strain relationship. Okay, so elasticity. What is elasticity? We will be dealing with elasticity. In simple terms, the property by which a body returns to its original shape after removal of the load is called elasticity. So I can give you an example. Here a hair ribbon is given. So this ribbon is having a specific length. Okay. So when you stretch it, you can see that when you stretch it, this will increase the length, and when you remove the force, the shape will regain. So it will regain to its original shape. So this material is a elastic material, and if it regains its fully original shape, it is having a length L, and when you stretch it and after removing the load, if it regains its complete original shape, then this is called perfectly elastic material. If there is a residual elongation even after the removal of the force, then that is not a perfectly elastic material. Steel, wood, stone may be considered as perfectly elastic within certain limits. So we will deal with the limit later. Next is concept of stress. So what is the concept of stress? First, before that, I ask you a question. Why we need stress instead of force and stress? What? So um, this is I am giving you as a question, and after the lecture you will find the answer, and you can comment it in the comment section. Okay, so here we will deal with concept of stress. So concept of stress is the internal force. So here you can say or resistance experienced in unit area against the external force applied in the body is called stress. So here you have a body is having cylindrical cross section area. Okay, so it is having a cylindrical cross section area of A, and the force is acted in this way. Force is acted. If it is in equilibrium, the same force will be acting in the other direction. At the other end, P force will be acting here. Here also there is the same cross sectional area will be there. Consider a section here. So this is the section. Here you consider this section. Sorry, this is the section. The internal resistance in, if you consider this section, the internal force, if you take this element, the same internal force will be also applicable here. So this has an area of A, and this P is acting, and at the intersection the internal resistance will be equal to P. So total internal resistance is equal to P, the total force acting. The total internal resistance is through how much area? It is through the area of A. It is acting through area of A. So the stress, or it is denoted by the letter sigma is equal to the total force acting divided by the total area. So this is the formula of stress. Here we note that we drawing the section again. So here this is P and this is also P, and you can see that this is the perpendicular cross. The area is taken perpendicular to the force, so you can easily find out sigma is equal to P by A, and the stress will be in this direction. If you take this the left side, and the stress will be in the perpendicular direction to the plane of stress. Since this is a perpendicular one, this stress is also called normal stress, or sigma here is equal to sigma n is equal to P by A. Okay. What is strain? It is the ratio of elongation of the body to the actual dimension due to stress is called strain. So here it is the ratio of elongation of the body to the what is the actual dimension of the material or the body due to stress is called strain. So for that we have a material or an element. It is having an initial length of L. It is applied by a force of P. At the end of application of the force, this got elongated to so this is called the elongation of the P, as you have seen when I uh, said about the elasticity in the example shown. This elongation is delta L. So the strain is equal to the ratio between delta L with respect to actual length L. So what is the unit of strain? The strain has no unit because here this is the unit of length, here also unit of length, so this has no unit. It is generally represented in percentage elongation. Here I want to ask a question to you. Why strain is important instead of elongation? So what is the significance of strain over elongation? So I hope you will answer the question in the comment section. Okay, so guys, I hope you got what is stress and strain. Now we will deal, or we will look into the relation between stress and strain. For that we will deal, or we will see an example conductor on a prismatic bar. This is the bar. Okay, so it is, let's take this bar is gradually loaded. First load is P1. So this is the actual bar length. This is the actual bar length. Now, due to the first load, it is deflected to delta 1 up to this much. Here the stress is stress strain, the stress is sigma 1 and strain is epsilon 1. Now the same load, it is the same number gradually increased to load to, this is the member, load to P2, the sigma 2 epsilon 2, and to again increased, it is increasing sigma 3 epsilon 3. So here you see the gradually increasing the stress and strain of a prismatic material subjected to a loading of P. What we see here, when you increase the load or the stress, the strain is increasing, and this strain is directly proportional to stress. You can plot a graph if you have. This is strain, stress, and if you plot the graph for the bar, prismatic bar, you can have a diagram like this. Graph, and you can see that up to a certain limit, the stress is directly proportional to strain. That means the slope is constant here. So slope is constant and stress is directly proportional to strain. The stress directly proportional to strain within a certain limit, so up to this point, this point is known as limit of proportionality. So up to limit of proportionality for a given loading, the stress is directly proportional to strain. This is introduced by Hooke's, and this concept is, or this is observed by the mathematician Hooke's, and this is known as Hooke's law. So what is Hooke's law? So what is Hooke's law? Hooke's law states that within proportionality limit, the stress is directly proportional to strain. Is stress sigma directly proportional to epsilon, that is strain, or you can take mathematically sigma is equal to some constant, we can take it as E into epsilon. So here this E is known as modulus of elasticity or Young's modulus. That is the modulus of elasticity. E is equal to sigma by epsilon, or The stress divided by strain is called modulus of elasticity. It is in the case of axial stresses or normal stresses and strain. So we have seen the what is elasticity, what is concept of stress, what is concept of strain, and now the stress strain relation. Okay, so in the stress strain relation, I wish to ask a question to you, that what is the difference between the limit of proportionality and difference between limit of proportionality and limit of elasticity? So I hope you will comment it in the comment section. So friends, I hope you like the video, and if you like the video, please share and subscribe the channel for more videos.